At this point, if you are taking Chemistry 216, Inorganic Chemistry, at the very minimum you've had General Chemistry 1 and 2. Some of you might have had Organic Chemistry or other courses, but General Chemistry 1 and 2 are required. I've already sent out a Quiz 0. The purpose of that is to scare you just a little bit, because Inorganic Chemistry is going to draw a tremendous amount of material from General Chemistry, and then we're going to expand upon it. The first thing we're going to find out is your knowledge of chemical bonding. I won't say it's wrong, it's incomplete. Let's put it that way. But to get to the more advanced things, you really have to be grounded in your general chemistry. And this is a lesson I learned very painfully as I move forward through my academic career, where I forgot the basics of general chemistry to a certain extent, and then I wondered why I was having such trouble in organic chemistry. So I'm going to go through aspects of general chemistry with our Quiz 0, answering some questions starting with quantum mechanics. Now the thing is, I'm gonna work through the problems of Quiz 0, but I'm not going to go through the full lecture of how I got there at this time. You should be going back to your general chemistry notes and the OpenStax chemistry book and reading the chapters that I suggested, specifically starting at quantum mechanics. I believe that's chapter 6 or 7, and then moving through chemical bonding. Quantum mechanics is that fundamental building block that gets us from essentially physics into chemistry. We go from things like the black body radiation, photoelectric effect, all the way up to chemical bonding. And obviously I skipped a few steps. So our quantum numbers derived by Schrödinger, those are absolutely foundational to know inside and out. The question you should ask yourself right now, I give you a value for n. I ask you, what are the possible values for L, M sub L, and M sub S? Obviously, do you know what N, L, M sub L, M sub S, what I'm talking about? What do those quantum numbers mean? If you don't know that, again, go back and start reviewing it. The reason why this is so critical, the quantum numbers build the periodic table. Okay? So when you're looking at the periodic table, you're actually looking at quantum mechanics, but in a graphical way. Now, to answer this question, we have to remember several things. N, our principal quantum number, I've given you a value for n, but n can be 1, 2, 3, to infinity, as long as it's an integer. Right? You can't have 1.5, 2.3, it has to be 1. The concept of quanta, that energy is transferred in packets. So you go from the first level to the third level, or the second level to the 17th level, but you can never be at level 4.3 or any integer value. Okay? That's a core of quantum mechanics. Our other quantum numbers, L, L is equal to n minus 1 through 0. Now, if n is equal to 1, then it's just 0. If n equals 2, well, then we get 1 and 0. So in this case, we have n equals 3. That means our possible values for L are going to be, and it doesn't matter the order that you write them in. Actually, yeah, let me 0, oops, sorry about that, to n minus 1. That way I'm just starting at the bottom. So we're going to have L is possibly 0, 1, 2, or 3. Okay? Now, with these quantum numbers, again, my expectation is that if this doesn't look familiar, you need to go back and read through the chapter on quantum mechanics. I would start at the beginning, which basically begins with waves, electromagnetic radiation, and just keep going, because we're gonna go through all of this. As chemists, what does this actually mean? What is L referring to? Well, L is referring to the angular momentum, but as chemists, we think of it more as our atomic orbitals. What orbitals are we talking about? This would be our s orbital, our p orbital, and our d orbital. So at n equals 3, we can have sp. By the way, one of the things as far as how I've written this question, you could go through and put all the different combinations of the numbers, the quantum numbers that we're going to go through. But again, I'm giving you how they're defined. So let's keep moving. M sub L, well, M sub L is defined, it's the magnetic quantum number. So M sub L is negative L through 0 to positive L. All right? Now, this particular term, again, is dependent on the value for L. So what that means is we're going to have a different M sub L for each one of these values. So when L is 0, M sub L is also 0. Okay? Well, s orbital. We have one s orbital available at each n value. Now, as you are going through these quantum numbers, my recommendation, have a periodic table with you, because we're essentially generating the periodic table as we go through each one of these values. So when L is equal to 1, now our M sub L, negative 1, 0, positive 1. Our p orbitals. We have one s orbital. When you get to the p orbitals, well, what happens? You get more. Let me take a step backwards. When we talk about the s block on the periodic table, it's groups 1 and 2. So you've got your hydrogen and your helium. Those would fill the s orbital, even though helium is in group 18, which I'll talk about that later. Well, when we get to L, now we're in the p block area, and now we have 6 elements that fill that. Well, each orbital, we'll see, holds 2 electrons. So what we're really talking about, px, py, pz, the 3 p orbitals. Again, px, py, pz. Now, when we get to L equals 2, our M sub L values are going to be negative 2 through positive 2. And this generates 5 orbitals, atomic orbitals. Again, we'll talk about like terminology like shell versus subshell and so forth. When you just simply write out the math, the quantum numbers like that, you don't have to worry about the terminology. It's just, it is what it is. Well, we have 1, 2, 3, 4, 5 atomic orbitals that we've defined. These are the d block elements, which are basically in the middle of the table. We did not go to n equals 4, which would give us L equals 3, which gets us to the F block elements, right? So we actually didn't go as far as we could. 5 orbitals are generated here. Each one can hold 2 electrons, again, 10 transition metal elements. Now, our last value is m sub s. This is the spin of an electron. And in this case, m sub s is actually negative 1/2 or positive 1/2. the fundamental difference between m sub s and the other three quantum numbers is that m sub s is defining a property of the electron. The other three quantum numbers are defining the orbital where the electron resides. The way to kind of think about it, the way I like to think about it, is NL m sub L, that's the address. And then, well, who you sending the mail to? Well, you have two choices. You've got negative or positive. So, or I'm sorry, negative 1/2, positive 1/2. And we'll see that this property of the electron, this concept of spin, is going to be very, very important. As we learn about transition metals, we're going to see that depending on the spin of the electron, that's going to make a huge difference in the magnetic properties of the transition metal complex and its optical properties. So there will be consequences as we go forward. So this gives us the definition of what values are possible when n equals 3 for the other three quantum numbers. And really, if you think about it, what I've actually done is I've filled the electrons through the D block elements. In other words, what you're going to find is you can use these quantum numbers directly on the periodic table.